So in this session, we have to discuss the chapter, one of the most important chapter and one of the interesting chapter of chemistry, and that is nothing but solutions. So we are going to revise the chapter solutions through some questions. Are you ready then, Maya? Huh? Ready or not? Yeah, okay. So let me explain the very first question of the chapter solutions. First question. A 1% aqueous solution of a certain substance is isotonic with a 3% solution of glucose. You must know the molecular mass of glucose. In this question, they give it as 180 and at a given temperature. And you are being asked to calculate the molar mass of the substance. So how can we calculate it? See, when you read this question, you can see some key words like when you're being asked to calculate the molar mass, right? The molar mass. And then you can see it is all about glucose, and they said it is isotonic. It's 1% and this is 3%, and at a same temperature. These are certain keywords to find out this answer. You know, when the solution becomes isotonic with another one, we have to say that its osmotic pressure are same. Osmotic pressure is generally represented with the letter pi. So we can say pi of glucose is equal to the osmotic pressure of the given substance. We can put it as S. And don't you remember what is the equation used to calculate pi? Pi is equal to CRT, right? Pi is equal to CRT. That means osmotic pressure is equal to CRT, where C is the concentration, R is universal gas constant, and T is absolute temperature. So we can substitute it here. Concentration of glucose into R into T, that is equal to concentration of the substance into R into T. You know R is a constant, so we can cancel R on both sides. Here temperature is also constant, so we can cancel temperature on both sides. So they said the concentrations are equal for both. And concentration is given by molarity, number of moles divided by volume of the solution. And in turn, this number of moles is represented with given mass divided by molar mass. So we can say given mass of glucose divided by molar mass of glucose into volume of solution. If it is in milliliter, no problem, we must multiply it with 1000. And here also, given mass of the substance divided by the molar mass of substance into volume of the solution, and if it is in milliliter, it should be multiplied with 1000. In this question, both are being mentioned in percentage, right? So you can cancel 1000 in both cases. Since both are in percentage, volume of the solution is same in both cases. It will be 100. And weight of glucose, they said it is 3%. So we can say 3 by molar mass of glucose is 180. That is equal to weight of the substance is 1 divided by molar mass of the substance. 3 by 180 will give you 1 by 60. Therefore, molar mass of the substance is 60. So here the right answer is option A. Is it clear, Tanmaya? Clear or not? Yeah. Shall we discuss the second question? Here is the second question. Here is the second question. The question is, when the concentration is expressed as the number of moles of a solute per liter of solution, it is known as number of moles of solute per liter. That is what we are calling as molarity, right? Yeah, so the right answer is option B, boy's answer, molarity. And there is another term you can see, that is nothing but normality. Whether you studied normality in your class, Tanmaya? Whether you studied it or not? Normality, whether you studied or not? I'm not getting any response. Hello, Tanmaya. Yeah. So normality is number of gram equivalents per liter of solution, and you know mole fraction as well as mass percentage. So here the right answer is option 2. Now here comes the third question. Colligative properties of solutions are those properties which depends upon, I hope you know the answer, depends upon the number of particles only. The right answer is option D. Don't you remember? Colligative properties are those properties which depends upon the number of particles instead of nature or size of the particles at all. So here the right answer is option D. Question number 4. From the following, the pair that shows least deviation from Raoult's law. Which of the following pairs will show least deviation from Raoult's law? So in turn, what they are asking is, which of the solution is an ideal solution? That is what they are asking. And remember, you must study the examples for solutions which behaves ideally, and the solutions which shows positive deviation, and the solutions which shows negative deviation. And the very first example, what we are calling as water and hydrochloric acid. Don't you remember? Water and hydrochloric acid is showing a negative deviation. It shows negative deviation. And second one is chloroform and ethanol. It is showing positive deviation. Positive deviation. Toluene and xylene, both are almost same in nature, right? Toluene is having one CH3 group while xylene is having two CH3 group, right? So they are almost same nature. Hence, it is not showing any negative or positive deviation, which means it's an ideal solution. When I'm saying a solution as ideal, then what will happen? It shows minimum deviation from Raoult's law, or we can say it obeys Raoult's law. So the solution which shows least deviation from Raoult's law is option C, toluene and xylene. And remember, ethanol and water, it is also showing positive deviation. To answer this kind of question, you must be familiar with the examples for negative as well as positive deviation solutions. Question number 5. The weight of pure sodium hydroxide required to prepare 250 cm cube of 0.1 molar solution is. You know, what is equation used to calculate molarity? Molarity is equal to weight of solute divided by molar mass of solute into volume of solution in milliliter, then it should be multiplied with 1000. This is equation used to calculate molarity. And in this question, they already gave what is molarity, what is the volume of the solution, and they asked for weight of the compound required. So you must calculate WB. So WB is equal to molarity, as they said, 0.1 into molecular mass of sodium hydroxide, 23 plus 16 plus 1. It is 40. 40 into volume of the solution. They said volume of the solution as 250, right? 250 ml divided by 1000, right? 1000. I hope it is clear for you. Now 250 is cancelled in 1000 for 4 times. 4 in 40, 10 times, 10 into 0.1. The answer is 1 gram. B is the right answer. Is that clear? Tanmaya, is that clear, dear? Hello? Yeah. Okay, Trisha is also here there. And anybody else? Trisha is attending the session and Tanmaya. Okay. Now, let me explain the next question. Question number 6. Which of the following colligative properties can provide molar mass of proteins or polymers or colloids with greater precision? Don't you remember? Osmotic pressure method. These are 4 colligative properties, of which osmotic pressure is that colligative property which can be used to calculate the molar mass of high molecular mass substances. In their case, the osmotic pressure is it is a little bit, you can read the value of osmotic pressure. If the compound C is of low molecular mass, then the osmotic pressure will be that much high. It will be too high to be measured. That is why we are not using osmotic pressure for calculating the molar mass of small molecules, and it is used mainly for calculating the molecular mass of bigger molecules like polymers, proteins, and colloids. So that's all about question number 6. So the right answer is option C. And the other methods are mainly used to calculate the molecular mass of small compounds like glucose, urea, sucrose, fructose, etc. Question number 7. What is the amount of water that should be added to 1 liter of 4 molar nitric acid solution in order to make its molarity 1 molar? This is a question related to dilution formula. And don't you remember what is the dilution formula? Dilution formula is M1V1 is equal to M2V2. They said molarity of the solution is 4 into volume of the solution is 1. That is equal to molarity is given as 1 into what is volume? You are supposed to calculate volume. So volume is equal to how much? V2 is equal to 4 liters. Is that clear? Hello? So what is the right option? Please type the option. For question number 7, what is the right option? A, B, C, D. Which is right option? Please type the right option. Tanmaya, Trisha. D. Tanmaya, are you there? Tanmaya? Yeah. Type the right option. Which is the right answer for this question? Trisha replied me. And what about Tanmaya? What is the right answer for this question? I'm not getting any responses. Tanmaya? Yeah. D. But the right answer is not D. The right answer is option C. Why? Read the question carefully. Then you can see the trap in the question. What is the amount of water that should be added? Here you calculated the volume of the solution should be 4 liter. Initially it is 1 liter, and now you have to make the volume of the solution as 4 liter. That you calculated by using this formula. But what they asked is, if you want to make the volume 4 liters, then how much amount of water should be added to it? That was their question. Is that clear? Is that clear? Yeah. So the answer will be V2 minus V1. That means 4 minus 1. The answer is 3 liter. And I hope it is clear for you why the answer changes to 3 liter instead of 4 liter which we calculated. Because read the question, they never asked about what should be the volume of the solution. If they ask so, then the answer will be 4 liter. But in this question, their question is very specific. They asked for what is the amount of water that should be added to that solution. Then the answer will be just 3 liters. I hope you got the logic. Question number 8. Solubility of a gas in a liquid is directly proportional to its pressure. This statement is called, all you know the answer for this question. This answer is Henry's law. Option A is the right answer. Henry's law. Now question number 9. If 0.5 gram of a solute, whose molar mass they said 100 grams per mole, in 25 gram of the solvent elevates the boiling point by 1 Kelvin, what is the molar boiling point constant of the solvent? So what they asked? Initially, when you read the question, you can see they asked for Kb. And don't you remember the relationship? Delta Tb is equal to Kb into molality. Kb into molality. And you know, in terms of this molality, you can write the equation used to calculate molarity. What is it? Number of moles of solute divided by weight of solvent. And if it is in gram, it should be multiplied with 1000. And again, instead of this NB, I am writing it as WB divided by MB. And here it is WA, that is in gram. So this is the final equation, and we are going to substitute for what? Kb. So what is Kb? Come on, tell me. Kb is equal to delta Tb. What is delta Tb? 1 into Mb. They said molar mass is 100. 100 into what is Wa? They said Wa is 25 divided by 1000. Is that clear? Did I miss anything? Yeah. Wb is also there. It is 0.5. 0.5. Yeah, 0.5. 100 has been cancelled. Now, 10 into 0.5 will give you 5. 25 by 5, the answer is 5. So, the Kb value is given as C. C is the right answer. 5 is the right answer. I hope it is clear for you, right? Yes or no? Hello? Hello? Is that clear? Yeah. Okay, good. Now, question number 10. I think question number 10 is missing. Okay, anyway, let us discuss next question. 11. Consider the two figures given below. Which of the following statements regarding the experiment is true? In one case, just W1 weight is placed over the piston, and there you can see 3 blocks, W1, W2, W3 has been placed. And a gas is going to dissolve in a solvent. So first option, solubility of a gas in liquid in beaker 1 is greater than that in beaker 2. No, because in beaker 1, a very low level of pressure has been applied. But here, a very high force is exerting, so very high pressure is applying. So, large amount of gas will be dissolved in beaker 2. So, that is wrong statement. Option B, solubility of gas in beaker 1 is less than that in beaker 2. That is right. In beaker 1, since low pressure has been applied, a small amount of gas will be dissolved. And in beaker 2, a large amount of force has been applied, so a very large amount of gas will be dissolved. Therefore, the right answer is option B. Is that clear? Yes or no? Yes. Question number 12. You can see X, Y, and Z in the above graph, and they asked, what is X? You know, X is the total pressure, and you know total pressure is nothing but P1 plus P2. That is what we are calling as the concept developed from ideal solutions. So P1 plus P2. And they asked for what is X2 here. You can see this is P2, and here P2 is 0, which means Chi2 or X2 should be 0 there. 0. And here, this is what we are calling as P02. Therefore, here only 2 will be present. Therefore, its mole fraction should be 1. Therefore, Chi2 that or X2 is set, and that set should be 1. Therefore, the right answer is option B. The total pressure X is P1 plus P2, and on the left end, mole fraction of 2 is 0, and on the right hand, mole fraction of 2 is 1. Therefore, Y is equal to 0 and Z is equal to 1. Now, let me explain question number 13. What are the conditions for a solution to become ideal? That means it should obey Raoult's law over the entire range of concentration. Don't you remember? For a solution to become ideal, its enthalpy of mixing, delta H, should be 0, and volume change during mixing, that should be 0, and total pressure, P total, should be the sum of individual partial pressures. That means PA plus PB. PA plus PB. And PA in turn is given by P0A into Chi A, and PB in turn is given by P0B into Chi B. Therefore, option A is the condition for a solution to become ideal, or we can say the condition for a solution to obey Raoult's law at all range of concentrations. So the right answer is option A. Question number 14. In an ideal solution, I told you that enthalpy of mixing is equal to 0. That statement is true, assertion is true. And why it is true? You know, when the components are sitting in a separate vessel, there is AA as well as BB interactions. When you mix them, there comes a new interaction, what we are calling as AB interaction. And this AB interaction should be same as that of AA as well as BB interaction. Then only the enthalpy of mixing, the delta V of mixing, everything turned to be 0. So all the interactions should be same. But in this question, they said AB interaction is lower than that of, which means the reason is wrong statement. So we can say C as the right answer. Assertion is true, but reason is false. I hope it is clear for you. What should be the reason? In an ideal solution, the AB interaction should be same as that of AA and BB interaction. That should be the right reason for this. But it is not given so. That is why reason is a wrong statement. And the reason will be true if it is a non-ideal solution. For an ideal solution, that statement is wrong. But if it is a non-ideal solution, then the statement is right. Okay. Now, question number 15. Osmosis does not take place in two isotonic solutions separated by semi-permeable membrane. Yeah, because if the two solutions are isotonic, then it represents their osmotic pressure is same. As a result, concentration of the solutions becomes same, so osmosis will not occur in that two types, so that kind of solutions. So that assertion is true. And let us read the reason. Isotonic solutions have same osmotic pressure. Yeah, that is what I said. Isotonic solutions have same osmotic pressure. That's why osmosis will not take place. So assertion as well as reason, both are same. I mean, both are correct. And reason is the correct explanation for assertion. So we can say A is the right answer. Question number 16. 0.1 molar solution of glucose has higher increment in the freezing point than 0.1 molar solution of urea. Wrong statement. Wrong statement. Because in both cases, the concentration is same. Therefore, number of particles present in both cases will be same. So both will have same freezing point. So assertion is a wrong statement. Now, Kf for both has different values. No. For a particular solution, the Kf value will be always a constant. So both reason and assertion are wrong statements. So we can put the right answer as option D. D. Let us discuss the next question. When dried fruits and vegetables are placed in water, they slowly swell. It happens, that is a true statement. When you enter into some fresh juice shops, you can see there the pineapple or carrot, they will put it in water so that becomes too fleshy, right? That will swell. So that assertion is a true statement. And it happens due to the phenomenon of reverse osmosis. Wrong statement. It happens due to the phenomenon of osmosis. Water from the surroundings will enter into these fruits. That's why it swells. It's not reverse osmosis. It is simply osmosis. So, assertion is true, but reason is false. Therefore, the answer is option C. C is the right answer. Now, question number 18. If on mixing the two liquids, the solution becomes hot, implies that it shows negative deviation from Raoult's law. What do you think? Is it a right statement or wrong statement? What do you think? Tanmaya and Trisha. True or false? If on mixing two liquids, the solution become hot, implies that it shows negative deviation. Don't you remember? If it is a solution which is having negative deviation, delta H of mixing is negative. Delta V of mixing is negative. When delta H is negative, it represents that it is an exothermic process. And if it is an exothermic process, heat will be released. When heat is released, the solution becomes hot, right? Yes or no? If a solution is showing negative deviation, it simply means its delta H of mixing is negative, which means the mixing process is exothermic. As a result, heat will be released. So the entire solution becomes hot. Is that clear? So that statement is true or false? Tell me here. Even if it went wrong, it doesn't matter. Tell me. I already explained it. Now you just say whether the statement is true or false. How can you say if on mixing two liquids, the solution become hot, implies that it shows negative deviation from Raoult's law. Now listen to my explanation. If a solution shows negative deviation, it simply means its delta H of mixing is negative. If delta H is negative, it means the process is exothermic. And if the process is exothermic, heat will be released. When heat will be released and you touch the solution, you feel the solution as a hot one, isn't it? When heat is released, you touch the species, what do you feel? Now tell me, is it true or false? Hello? Hello? Did you understand what I said? Yeah. Now, is it true or false? True. That's it. So assertion is true. Now, solution which show negative deviation are accompanied by decrease in volume. Yeah, I told you now. If a solution is showing negative deviation, its delta H as well as delta V are negative. So there will be a decrease in volume. So reason is also true. Sorry. But the reason is not the correct explanation for assertion. Why a solution is showing negative deviation or why the solution is releasing heat? The answer is AA interaction and BB interactions are there before mixing. And when you are mixing it, a new interaction, what we are calling as AB interaction, has been generated. And that AB interaction is too strong. That is why a large amount of heat has been released. That is why the volume has been decreased. So the reason should be that one, that AB interaction is much stronger compared to AA and BB interaction. That reason is the correct explanation for the assertion. But unfortunately, reason is also another statement. It won't be the explanation for the assertion. So we can say that option B is the right answer. That means assertion as well as reason are true, but unfortunately, reason is not the correct explanation for the assertion. So B is the right answer. Is that clear? Hello? Hello? Okay. Now, question number 19. Water boils at 373 Kelvin as the vapor pressure at this temperature becomes equal to atmospheric pressure. Yeah, that's a true statement. You know that the boiling point of water is 373 Kelvin. And you know that boiling occurs when the vapor pressure of the liquid becomes equal to atmospheric pressure. So that assertion is a true statement. What about reason? Vapor pressure of water is less than 1.013 bar at 373 Kelvin. Wrong statement. We know that the atmospheric pressure is that 1.013 bar. That is standard pressure. You know that. And at 373 Kelvin, boiling is occurring, which means the vapor pressure of water is equal to atmospheric pressure. That means vapor pressure of the liquid should be 1.013 bar. Then only the water will boil. So reason is a wrong statement. So we can say assertion is true, but reason is false. The right answer is option C. C is the right answer. Is that clear? Tanmaya and Trisha. Yeah. Trisha, are you there? Trisha? No. Okay. Maybe some technical issues. No problem. Question number 20 and 21, it is supposed to be followed by a case study. So listen to that case study. Osmotic pressure is widely used to determine molar masses of proteins and polymer. The solutions having same osmotic pressure are called isotonic solutions, and water can flow in or out from the substance depending on if it is kept in hypertonic or hypertonic solution. And the direction of osmosis can be reversed if a pressure larger than osmotic pressure is applied on solution side. So this is all about osmosis. You can see isotonic solution, hypertonic solution, as well as hypertonic solutions. And the direction of osmosis was also mentioned there. And let us discuss the questions. You all know that preservation of food articles, preservation of meat by salting, or fruits by adding sugar, protects them from bacterial action. And how? That is what they asked. How? You know, when you keep meat or fruits in a highly concentrated solution, you can increase the concentration either by salting or by adding sugar. What is actually happening? If there comes a bacteria, the bacterial cell wall will act as the semi-permeable membrane, and the water which is present inside the cell of this bacteria will undergo osmosis. That means it will pass through the semi-permeable membrane to the outside area. So as a result, the bacterial cell will shrink. Hence, it will die. So in that way, we can destroy the entire bacteria or the growth of microorganisms in meat and fruits by adding salt or by sugar. So we can say what is the right answer. Due to osmosis, bacteria lose water on salted meat or candied fruit and it will die. So the right answer is option B. B is the right answer. B. Question number 21. Seawater is desalinated to get fresh water. By which of the following methods? This is what we are calling as desalination of seawater. And don't you remember? It is having two chambers, right? Two chambers, sorry. One is having seawater and the other one is having pure water. And this is what we are calling as SPM, semi-permeable membrane. And normally, water from this pure water zone will enter into seawater through the semi-permeable membrane. And it is what we are calling as osmosis. It is what we are calling as osmosis. Now you can see there is a piston on this seawater zone. Using that piston, you can apply force or you can apply pressure. And when you apply pressure, initially the rate of osmosis will slow down. Now you should not stop. You should increase the pressure. then what will happen? Then slowly osmosis, the pressure becomes equal to osmotic pressure, and once the pressure becomes osmotic pressure, the entire the entire process of osmosis will stop. The entire process of osmosis will stop. I hope it is clear for you, right? Hello, is that clear? Hello? Yeah, I hope so. Now, you should not stop there. You should increase pressure more than what? The osmotic pressure. And if you apply a force or a pressure more than the osmotic pressure, then water from the seawater zone will move to pure water zone. That means the solvent molecules from high concentration is moving towards low concentration zone. That is what we are calling as reverse osmosis. What we are calling as RO, reverse osmosis. So I hope it is clear for you what is meant by reverse osmosis, because in osmosis, generally what will happen? Generally, solvent molecules from low concentrated zone, or we can say from the solvent zone, will enter into a high concentration zone, or we can say to a solution. But when you apply a pressure equal to osmotic pressure on that solution or high concentration zone, then osmosis will stop. And if the applied pressure is greater than the osmotic pressure, then what will happen? Then the solvent molecules from the high concentration zone or from the solution zone will enter into solvent zone or low concentration zone. This process is what we are calling as reverse osmosis. I hope it's clear, right? Yeah. So that's all about the questions of the chapter solutions. I hope you all, Tanmaya, you are only there. Tanmaya got the concept of solutions. And my dear Tanmaya, let me tell you one thing. This chapter contains a lot of numerical problems and all. So you should refer to the numerical side of the chapter solutions. Initially, you know the concentration terms, then some questions based on Raoult's law, then some questions based on Henry's law, some questions based on colligative properties and all. So you should practice all those questions to get a more clarity over that chapter. Is that clear, Tanmaya? Yeah. And I think we finished all the chemistry chapters, right? Or any chapters is left? Because I took a solid state, p block elements, and this one, right? Which one? Solutions. And haloalkanes and haloarenes is already finished, right? Right, Tanmaya? Alcohols is also finished. Okay, okay, Tanmaya. No problem, no problem. Actually, you're from where? Where is your native place? Kannur. Okay, okay, okay. I went there at year 2008 or 9. I took classes there. One of my friend's institution, but now that institution is not there. Okay, no problem. And you are a new student. And what about your friends? Whether you informed your friends about the class? Huh? Yes. And whether you like the class? What a question, sir. You are asking about your class. And how can I answer that your class is not good? Come on, tell me. Hello? Google, sir. Huh? I think you said good, sir, right? Okay, okay. No problem, dear. I was excited when because I got this comment for the first time that Google, sir. Okay, no problem. So I think the way you are supposed to study the chapter is clear for you, right? Uh, the numerical side, that means the concentration terms and all other terms. I hope it is clear for you, right? Yes or no? Yes. And my dear Tanmay, let me tell you another thing. I think regarding chemistry, I know haloalkanes has been finished, alcohols has been finished. Now biomolecules is there. We had to discuss biomolecules, and the P block along with solution, solid state, all those chapters are already finished. No problem. But still, you are supposed to study all those chapters, right? So if you feel any difficulty in following any those chapters, you just contact Anjana ma'am. I hope you have her number, right? Do you have Anjana ma'am's number? The lady who informed timetable? Yes, yeah. So if you need any assistance regarding any chapters of chemistry or physics or maths or biology, you should inform her because you are at the end of the session right now. Because we have 4 or 5 days more for winding up the entire class. So if you need a class, for example, you are saying that Anjana ma'am, I'm not that much confident in the chapter haloalkanes and halorines. So if possible, should I get a special care on that? Then HomeSkul will give it to you. So it should be informed, okay? And not only you should inform it to your friends also, because once many students are in the class, we the teachers who are taking the chapters will also get excited, and that will give you more. Actually, in today's class, even if a lot of students are there, I can't do anything because I'm not well actually. uh, Not because of any COVID. It's just a viral infection. So not the COVID virus, it's a simply some kind of viral infection, so I'm not well actually. But I hope the class is good, right? I just to practice. That means you need questions to practice. You need more questions regarding all the chapters to practice, right? No need, sir. Okay, 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 okay. Anyway, dear, you study well the chapter, and if you have any doubts not only regarding this chapter, regarding any subject, any chapter, any topic, inform Anjana ma'am to get a special session. Okay, we will be ready for you to give a special session because remember, this is your term one examination. That means board examination. So there is no way to gamble it, right? So you should study the topics well. Anyway, I'm winding up the session right now. So once again, study well. All the very best. Thank you very much. And have a great evening. Bye. You have a tuition. Where? Where you are studying? Huh? Online. Online, which institution you are using? Don't worry, yeah. Just tell me. Uh-huh. Great. So your mother is teaching you a chemistry, right? Whether she will teach you or whether it will end up with. Yeah, okay, 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 fine, fine, fine. Okay, and in which institution you are actually studying? Huh? Personal tutor. No. I'm asking that. Are you? Uh, you're studying in which school? Chinmaya. Okay. And you, whether you are writing any entrance examination for JE engineering or medical, any kind of entrance examination? Not now. You have to practice it for now, dear. Don't think about losing 1 year as a repeater. If you have any plan to do MBBS or engineering, time to start the preparation right now. Don't plan to skip 1 year as a repeater. Okay, just a suggestion, just an advice. Okay. Anyway, Tanmaya, if you need any help or any support, please contact me. Okay. And let me tell you my name. I'm Sony. I hope you saw my name in the chat box, right? So I'm Sony C. Francis, the regional head of HomeSkul. Okay. Anyway, thank you and all the very best, Tanmaya. Have a great evening.